Good day. Today we are looking at November 2021 paper 2 question 3. This is an analytical geometry question and we're going to analyze and interpret what we are given first. So it says in the diagram A has coordinates -2 and 10, B is KK, and looking at that, that's telling us already that the y and the x value will be the same value, okay, because it's the same variable. They give us C to be 4 to -2 are the vertices of triangle ABC. Line BC is produced to H, here's H, and it cuts the axis at E, which has the coordinates 12, 0. AB and AC intersect the x-axes at F and G respectively, and we've got an angle of inclination of AB to be 81.87 degrees. Okay, the first question says calculate the gradient of BE. So looking at B and E, we don't have coordinates for B, but we do have C, which is on the same line. So we can use that to help us calculate the gradient of BE. So this is 3.1.1, okay? And what we're supposed to be calculating is the gradient. Just fix my 3. We're supposed to be calculating the gradient of BE, but we don't have B's values, so we're going to calculate the gradient of CE. You should know your gradient formulas so that you don't have to be scrolling up and down between the formula sheets. So gradient formula is y2 minus y1 over x2 minus x1. Okay, our C is 4, -2, and my E is 12 and 0. So make sure you're using the correct value. So if I'm starting with E, then this is going to be my E2, my x2. This is going to be my x1 and my y1. Okay, so my y2 is 0 minus -2. Be very careful with your signs. And my x2 is 12 minus 4. So it's going to be 2 over 8, which can be simplified to 1 over 4. Okay, 2-mark question. Very simple in mark allocation. 1 for substitution of the values for C and E, and 1 for my answer. So I'm going to write my answer here. My gradient of BE is 1 over 4. Okay, now we are going to calculate the gradient of AB. Okay, so taking a look at our graph, we know that we don't have yet the coordinates of B. How are we going to find the gradient of AB? Well, they give us the angle of inclination. So that is a big clue, because you should know that this is 3.1.2. Okay, you should know that the angle of inclination, so the gradient of AB, will be equal to tan of 81.87 degrees. And that is therefore going to tell me that the gradient, if we put that into our calculators, is 7. Okay, simple 2-mark question for substitution and the answer. Okay, so here we got the gradient of AB to be equal to 7. Okay, so we are well on our way with this question. Let's read the next question. The next question says, determine the equation of BE. So we're looking along that same line. We want to find the equation of BE in the form of y is equal to mx plus c. Also fairly simple, because we already got the gradient to be 1 over 4 here in 3.1.1. So we just need to find our c value, okay, which is where it is cutting the y axis. Okay, so 3.2. Let's see, so we've got y is equal to, we know my m is 1 over 4, x plus c. We are substituting, so we're going to substitute, let's substitute e, which is 12 to 0. Okay, my y is 0, 1 over 4, 12 plus c. So 0 is equal to 3 plus c. C. We're going to take the 3 to the other side. It's going to be negative 3 is equal to C. Make sure you write your answer as a full equation. So y is equal to 1 over 4x minus 3. Okay, another 2-mark question for substitution of the values of E and your answer. Okay, so I am going to write that here though on my graph. So we got this to be, the equation of this line to be y is equal to 1 over 4x minus 3. Just so that we can remember that when we need it. Okay, now it wants us to calculate the coordinates of B. And it's telling us where the values of k are less than 0, which we can see from our quadrants because it's in the negative section of the y values and in the negative section of the x values. So we're calculating the coordinates. How are we going to calculate the coordinates? So what I can see already is that we know the line equation. We just calculated the equation for BE, for the line of BE. So we can substitute k and we can find our coordinates. So 3.3.1, we're going to substitute B, which is k. Because it is both the same variable, we're just solving for one variable. So y is equal to 1 over 4x minus 3. We're going to substitute. So k is equal to 1 over 4k minus 3. So it's going to be k, which is actually just 1, minus 1 over 4k is equal to 3. This is going to give me 3 over 4k is equal to 3. Now I would ask you to use your calculator and we're going to divide by 3 over 4 on both sides, or you can say that we're going to times by 4 over 3. Okay, and if we do that, what do we get left with? K is therefore equal to remember that this is negative 3. K is equal to negative 4. Okay, so therefore my coordinates of B is negative 4, negative 4. Okay, let's write that in here. So it's no longer just kk. We now know that it is negative 4, negative 4, negative 4, and negative 4. Okay. Next question says calculate the size of A. Now where is A? Here is A at the top here. Okay, so we want the size of this angle. Now what I would say is the best is that we've already been given this one angle, 81.8. So I'm going to want to work in the triangle AFG. Okay, if I can find the gradient of AC, because I have the coordinates of A and I have the coordinates of C. So if I can use angle of inclination to find this angle value there using the gradient, then I can use exterior angles of a triangle to give me the value of A. So step 1, this is a 4-mark question, so let's be very careful here. So 3.2. Step 1 is I want to find the gradient of AC. Okay, so it's going to be minus 2 over minus 2 minus 4. So that's 12 over minus 6, which is giving me minus 2. Okay, that was step 1. That was finding the gradient. Now to get the angle of the angle there, we need to use tan. So tan theta is equal to the gradient, which is negative 2. You are going to put into your calculator theta is equal to shift tan 2, and then you're going to get the angle of theta to be 116.57. Okay, that is now my angle of inclination here. This angle is 116.57. Now we are looking, step 3 is we are going to say in triangle AFG. Angle A plus angle F is equal to 116.57. We are finding angle A, we know angle F, so therefore angle A is going to be 116.57 minus F, which is 81.87. And now we can simply put that into our calculators and we're going to get A to be 34.70 degrees. 4-mark question, so you had to be very careful here. First mark was for finding the angle of AC. Second mark was for tan theta equal to -2. Third mark for your angle, and last mark for your answer. Okay, that's why I wanted to break it down into steps so that you could see the full picture. Okay, so let me just write out my angle here. It is 34.70. Okay, now let's move to our next question. Okay, the next question says that they want the coordinates of the point of intersection of the diagonals of a parallelogram ACES, where S is a point in the first quadrant. So we are creating a parallelogram ACE, so here's E, we're going up, we're connecting, but they want the point of intersection. Okay. So if we were to calculate the point of intersection, what I would think we should do is we should find the midpoint of A and E. So let's see what that is. So we're finding the midpoint of A and E. So how do we find that? We're going to add, so 12 plus minus 2 over 2, that's for my x value midpoint, and my y value is going to be 10 plus 0 over 2, and so it's going to give me 10 over 2 and 10 over 2, so the midpoint is going to be 5, 5. Okay, fairly easy question, just finding the midpoint, and you had to understand what they were asking you, that if we were to draw this parallelogram, that we could only find the midpoint using A and E. Okay, let me erase this out so it doesn't confuse us. Okay, next question. We've got another point that's being added in. T, PP, where P is greater than 0. So if it's both P's are greater than 0, it's telling us that it's in quadrant 1. So it's in this quadrant here. Is plotted such that ET is equal to BE, and they're giving us units. Calculate the coordinates of T. Okay, 5-mark question. I don't think it should have been 5 marks because I think this is fairly easy. We're wanting to calculate the coordinates of T. So they are telling me that BE, so this is 3.4.1, they're telling me that BE is equal to ET. And we know now that the coordinates of T is P and P. We now just need to use distance formula to help me. So they give me the value for root 17. Now I'm going to use distance formula. So the coordinates of E is 12, 0 and T is P, P. So let's put that in the square root. Distance formula, 12 minus P squared plus 0 minus P squared. We're just solving for P now. So we're going to root both sides, square both sides is what I would do. On this side, when I square it, I'm going to get 272. On the other side, when I square it, I'm going to get rid of the root, which is going to leave me with 12 minus P squared plus 10 minus P, 0 minus P squared. And if it's 0, that just leaves me with P squared. And negative P squared is just going to be P squared. So we need to now expand this 12 minus p, which is going to give me 144 minus 24p plus p squared plus the other p squared. Now, simplifying, what do we have? We get left with simplifying. So we've got 2p squared minus 24p is equal to 144 minus 272 equal to 0. So 2p squared minus 24p, oh sorry, that was meant to be a minus here, minus positive 144 minus 272. So we need to put that in our calculators. 144 minus 272 gives me negative 128 is equal to 0. Now as you can see, I can divide every item by 2 to simplify. So I'm going to be left with p squared minus 12p minus 64 is equal to 0. I can get my brackets out now. P, and my terms are going to be 16 and positive 4. Therefore, p is either equal to 16 or p is equal to negative 4. But in this case, they told us specifically where p is positive. So therefore, p is equal to 16. And my coordinates for TT is 16, 16. Long question. It was just about doing the correct calculations and simplifying correctly and calculating correctly. Okay. 5 marks. So substitution of E and T was 1. Equating, another mark. Standard form, here's my standard form. Factors, and my answer. To be specifically 16. If you didn't say 16 was the answer, you didn't get the final mark. Okay. Okay, let's look at the next question. So we got my coordinates of t to be 16, 16. Next, it says determine the equation. So we're finding equations for 2 questions. Determine the equation of a circle with its center at E, but it's passing through points B and the t that we just calculated. So the t that we just calculated is far off actually, because if this is 12 here, it's got to be around 16 somewhere here. And this is 10, so it'll be very far up, 16 somewhere there. But we know that it's passing through B very far, and we know that E is the center of the circle. So this circle is actually not accurate at all. But E is the center of my circle. And if E is the center of my circle, then we know that, and B is at a point passing through B and T, that can tell me that I can know the radius, okay? Because I just got told what the length of BE is. So I know the radius for my equation. What else can I put into my equation? So 3.4.1, I already know quite a lot. So I'm using E as my center, so therefore it's going to be x minus 12 squared plus y squared, because there's no y value, it's 0, is equal to 4 root 17 squared. If we put 4 root 17 squared into my calculator, it's going to give me, so my equation is going to be x minus 12 squared plus y squared is equal to 272. Very easy question. The next one saying, determine the equation of the tangent to the circle at B. So if we are working with the tangent, how are we going to find the gradient? We know that the tangent is perpendicular. So if the gradient that we calculated earlier of BE was 1 over 4, the gradient of the tangent is therefore going to be negative 4. Because the gradient is perpendicular, and we know if it's perpendicular, they multiply by each other to give me negative 1. So now to find the equation, y is equal to minus 4x plus c, we can substitute our values for k, which is negative 4. So we're going to substitute b. So we're going to get negative 4, we substitute, plus c, negative 4 is equal to negative 4 times negative 4, 16, plus c, negative 4 minus 16 is equal to c. C is therefore equal to 20. So therefore, the equation of this line is going to be y is equal to negative 4x minus 20. This was a bit of a 3-mark question, and that extra mark with this question compared to the previous question came with finding the gradient of the tangent. Then substitution and your answer. Okay, in total this was a 24-mark question, but I feel like students could have easily gotten marks here by just doing what they know. For analytical geometry, make sure you know your tangents, how to calculate using a tangent and a gradient, you know your distance formula, your midpoint formula, and your gradient. Those 3 formulas are vital for you to know, and it saves you a lot of time having to scroll back and forth learning your formula, especially for analytical geometry, where there's generally not many questions for analytical in a paper. Thank you so much for listening. I hope that you understand and you enjoyed this video.